one thing I talked about as you all started the warm up is these problems are essentially setting us up for how we're going to work through the actual problems we're solving today. So, what you're noticing is we have fractions. What we need to think about these as are just division problems. So, how do we undo dividing? Just by multiplying. Okay, so that's like a big thing to think about today. We're undoing division and we undo it through multiplying. So 1a, that's x divided by 3. So I'm going to multiply by 3 and that gets rid of the dividing. So x is equal to negative 5 times 3, which is negative 15. Done. Nothing more that we need to do. Okay, 1b, essentially the exact same thing. Now the variable's on the right. So I see x divided by 5. So I'm going to start by multiplying by 5. When I multiply by 5, that gets rid of the dividing by 5. I want to continue to emphasize you to cross off the operations that undo each other. Okay, otherwise, a lot of you will keep those operations going as you keep writing your equation. So that leaves x on the right, and it's equal to 5 times 4, which is 20. All right, but now with 1c. 1c, if I read the left side, that's 15 divided by x. It's the dividing by x that makes this one a little odd. So I'm like, well, how could I undo dividing by x? Well, the same way that I would undo dividing by a number, and that'd be to multiply. So we'll multiply by x. That gets rid of the dividing. And so now I have 15, and it equals negative 3 times x, or negative 3x. So again, the main thing we're working on today is undo the division. Once the division's gone, it's going to look like an equation that we've solved already. So now I have one more thing to do here. I now need to divide by that negative 3 to get the x by itself. And so x is equal to 15 divided by negative 3, which is negative 5. Okay. So that's essentially how we're going to go about the whole work today. Now, if you look at the examples after the warm-up, it's a fraction equal to a fraction, or a division problem equal to a division problem. The first set of problems, we're going to undo the division in 2 separate steps, and then I'll show you a shortcut that makes this a little bit easier. So starting on either side, again, the main thing we want to accomplish is to get rid of the dividing. So the first thing I'm going to do is I'm going to multiply both sides by 2 to get rid of the dividing by 2. So multiplying by 2 gets rid of the dividing by 2. And when we multiply the other side, and the way that you multiply fractions is the tops of the fractions get multiplied together. So 7 times 2 is 14. And then the bottom of the fractions get multiplied. How can I make 2 a fraction? Yeah, put it over 1. Okay, so 7 times 2 is 14. That's the new numerator. The denominator is 6 times 1, which is still 6. So does that denominator change at all? No. So when you undo the division by multiplying, it's always being applied to the numerator. You're never multiplying the denominator by anything. Okay? In this case, we're done. Right? X is by itself. We don't need to undo the dividing by 6 because we're always trying to accomplish getting x by itself here. So our answer is x equals 14/6. That would be, let's see, 2.33 repeating. Okay, if you wanted it as a decimal. Okay. So nothing really too crazy there. We just had to do it in one step. But now, number 3. What you're going to notice is we have more work to do here. Okay, and stop with the faces. Keep your attention up here. Okay, there we go. So if I start with the left side, that reads as 6 divided by the absolute value of x. It's the dividing by the absolute value of x that makes this tricky. So the first thing I'm going to do is undo the dividing by the absolute value of x by multiplying. We're doing that to get rid of the dividing, so let's cross those out. That way we know the absolute value of x is not on that left side anymore. Then all we have is 6. And then again, how we multiply the right side and with that fraction is what we're multiplying by, we'll multiply to the numerator, so 18 times the absolute value of x is our new numerator. The denominator is really getting multiplied by 1, and thus it is not changing, so it's still divided by 15. I want to pause there for a second. Is there any questions with how I'm getting any numbers in this second step here? Yeah. That's a great question. Because that is us undoing the dividing by x. And so it's how we're still undoing operations in an effort to work to figure out what x needs to equal. Okay, so we can multiply by anything. We can multiply by variables, by numbers. All we're trying to do is, especially in this case, undo the dividing, and that way we get to an equation that allows us to solve for x. Okay? Yeah, go ahead. So let's keep going. Now when I read the right side, where my variable is at, I still have division, right? That's 18 absolute value of x divided by 15. I'm going to multiply both sides by 15, and that's how we undo the division. So the right side is 18 absolute value of x. The left side is 15 times 6, which is 90. And look at that. We have now finally gotten rid of all the division. Once we get rid of all the division, it turns into a problem that we should be a little more familiar with. So now we need to figure out, or how to get the absolute value term by itself. Let's dividing by 18. 90 divided by 18 is 5. So the absolute value of x is equal to 5. Remember that once we have the absolute value term by itself, that's where we'll take what's inside those absolute value brackets and set it equal to the positive and negative numbers. And that's how we get the two solutions there. So this is the kind of work we're going to be doing for most of these problems. Okay. Well, again, let's go through the next two together, and then I'll have you start to do some of the work on your own for the back sets of problems. And again, starting with undoing all the division. Okay, that's always our first thing we're trying to accomplish here. So the left side, 16 divided by 7, we're going to start by multiplying by 7. Gets rid of the dividing. So the left side is 16. The right side, again, the 7 only multiplies to the numerator. The denominator just gets multiplied by 1, so it won't change. So here I have 4x squared times 7. We're basically distributing that 7 to the 4x squared. That makes that 28x squared, and still divided by 28. The denominator, again, is 28 times 1, so it doesn't change. Now, there are other shortcuts here, and some of you might already be seeing some of those, like, hey, multiplying of 28 and dividing by 28, those are 1, so they essentially cancel out. But I want to keep our work consistent here where we're still accomplishing getting rid of the division. So now, I'm going to multiply both sides by 28 to get rid of the dividing by 28. So that goes away. The left side is now 28 times 16, which is 448, and it equals 28x squared. As soon as we undo all the dividing, it's much more comfortable for an equation that we've seen previously, okay, just different numbers. So 28 times x squared, I need to divide by 28. So 448 divided by 28 is 16. That's a nice number. So x squared equals 16. And then we can square root to undo the squaring. And so x is equal to the square root of 16, which is positive and negative 4. Okay. Again, any questions so far? All right. Number 5, and anytime we have these exponential terms, to me, these are ones that can be a little bit tricky here. So let's start the exact same way. Let's get rid of the dividing on the left side by multiplying by 8. Gets rid of the dividing. So the left side is 2. The right side, the 8 will multiply to the 40, so that's us multiplying the numerators together. 8 times 40 is 320, I believe. And then the denominator is getting multiplied by 1, so it's still 10, 2 to the power of x's. So if I read that left side, it's 320 divided by 10, 2 to the power of x's. We want to undo the dividing of the 10, 2 to the power of x's. So now I'm going to multiply both sides by 10, 2 to the power of x. That gets rid of the dividing of that term. And so on the left side, we're multiplying this entire term by 2. We've talked about a lot with the exponentials that the base can't change. So this 2 is changing however many we have of 2 to the power of x. So 2 times 10 is 20, 2 to the power of x. And it equals what's left over on the right side, which is 320. Now we're in a place where we can start to work to get the x by itself. So divide both sides by 20. So 2 to the power of x equals 320 divided by 20, which is 16. And so we need to figure out 2 to what power is 16. Let's start with 2 squared, which is 4. 2 cubed is 8. 2 to the power of 4, hey, that's 16. That tells us that x equals 4. Okay. Go and flip the page over. And let's start, I'm going to give you hints. I'm going to have you try the top 2. Here's the hints. Because that is x plus 8, put parentheses around that. In fact, not a bad idea to just put parentheses around everything. And you'll see why when you go to multiply. So you know what? I'm going to do 6, and then you all can try the next one. Okay, here's why the parentheses are really important. When I first undo the dividing by 7, which I'm going to do by multiplying by 7, what happens is we still have this 3, but on the right side, I have 7 that multiplies to the numerator, which has 2 terms. The reason why I wanted to add the parentheses is because it makes it a little more clear that that 7 is going to distribute. Okay, so in the numerator, it's x plus 8 times that 7. 7 times x is 7x. 8 times 7 is 56. The denominator only gets multiplied by 1, so it just stays as 21. Okay, so that can be really sneaky. Okay, and I'll often see that students will only multiply the 7 to the x or just to the 8. Next thing we need to do is undo the dividing by 21 by multiplying by 21. Gets rid of that dividing. So now 21 times 3 is 63, and it equals 7x plus 56. And now we're ready to start solving the way we have been throughout this entire unit. So first, subtracting the 56. That is 7, and it equals 7x. Then divide by 7, so that x is equal to 1. Okay. Number 7, I'm starting by undoing the dividing by 9 on the left. by multiplying by 9, it only multiplies the numerator. Again, that's just how we multiply fractions, numerators with numerators, denominators with denominators. So the denominator gets multiplied by 1, and it remains as the absolute value of x minus 3. So here's the part that's tricky, is now we need to undo the dividing of the absolute value of x minus 3 by multiplying by it on both sides. This is why we added the parentheses, because those stay grouped together. So when I multiply by the absolute value of x minus 3, it gets rid of the dividing, and that absolute value of x minus 3 gets multiplied by 2, making it 2 absolute value of x minus 6. Now the division is gone. Now it's like a problem we solved before. So distributing that 2 is 2 absolute value of x minus 6. Adding the 6, I have 2 absolute value of x equals 96. Dividing by 2 is how I get absolute value of x equal to 48. And so x is equal to positive 48 and negative 48. And again, I'm not going to sit up here and say that these are easy, because they're not. These are hard. So now, let's talk about a shortcut that makes our lives a little bit easier. Anybody ever heard of cross multiplying? Okay, the reason why I don't teach it right away, okay, because I think it's important to understand what we're doing when we cross multiply. Okay, so here's what cross multiplying is, and I'll explain how it relates to what we just did. To cross multiply, you take the denominator of one fraction and multiply it by the numerator of the other. Okay, so as soon as we know what we're going to cross multiply with, we write that down, and it doesn't matter which side of the equation we write it down on. Okay, so 6, and then that needs to multiply, let's put parentheses there, to the 2x squared plus 5. Then it is equal to the other cross being 5 times 18. And look at that. All the division is gone in one step. Okay, so the reason we didn't start with this, because it's still important to understand what we're doing. What we're doing when we get here is we're just bypassing getting rid of the division in 2 individual steps. We can do this all in one, right? Where if I solve this the way we first described, I multiply both sides by 6. The 6 multiplies to the 2x squared plus 5. And then multiply both sides by 18, where the 18 will multiply by 5. Okay, so let's look at the next one here. Okay, let's just do the cross multiplying part. Okay, so look at this again. The right side, or all these, I'm going to put parentheses around it because there's more than one term there. I'm going to take the denominator of one fraction, multiply with the numerator of the other. Again, it does not matter which side of the equation we write it on. So 7 will multiply to 2 6 to the power of x's minus 4, and then it's equal to the other cross,